Homework sheet 5 tutorial video here. Reasonably straightforward one. I've got a fair bit filled in just because sketching graphs on here is a bit of a challenge, so I wanted to get it accurate beforehand. I'll try and highlight any key features of what I'm talking about as we go. So for this first question, y equals 2 of sine 2x plus 3, our period is 2 pi divided by whatever is in front of the x, which in this case is 2, leaving us with a period of pi. Our scale is always whatever our period is divided by 4, so I just like to do that so I get a bit of a sense of the shape. And a lot of students that I've spoken to about this one started jumping straight in to try and find x-intercepts, but there won't be any. Because we've moved up 3 units and have an amplitude of 2, our maximum is 5 and our minimum is 1. So maximum 5, minimum 1. And then we can get onto sketching it. So you can see our marking scheme there. So the shape would be 1 mark, getting our endpoints labeled, and getting the maximum and minimum correct. So that's 3 marks for sketching that. Again, hopefully in an exam or test, you'd have a grid with a bit more detail, but we need to fill everything in there. So for question 2, y equals 2 tan 2x plus 2 between negative pi and pi, we need to clearly state the equations of asymptotes, and that's a good first point to give us a bit of shape to the function that we're working on. So here we always do pi on 2, we can write it as pi on 2 equals whatever is in the tan function, in this case being 2x. That's the same as pi on 2 divided by 2, which gives us pi on 4. So that is our first asymptote. And just like solving for x-intercepts, we then add or subtract the period, which is pi on 2, giving us negative 3 pi on 2, negative 3 pi on 4, negative pi on 4, pi on 4, and 3 pi on 4. That would be the first thing that I would sketch in the shape of this function. So you can see we've got those different x values. I just realized I don't have marking schemes for this. I'll write that up in just a second. We can then find our x-intercepts by solving tan of 2x equals negative 1, which gives us 3 pi on 4. 2x equals 3 pi on 4. Again, adding and subtracting our period of pi on 2 gives us all of these values here. So we can then sketch reasonably accurately. My green line there of y equals 2 is just representing that vertical translation of 2. And you can notice that I've got open circles for those endpoints, a really important feature there, as the question did have curved brackets when stating the domain. But we've got our x-intercepts, our asymptotes, equations of asymptotes. Let's put the marking scheme on. So 1 mark for all the asymptotes, 1 mark for our left-hand endpoint, 1 for our right-hand endpoint, 1 for all of the x-intercepts, and 1 for shape, giving us 5 for that question. Key part of question 2i, seeing that this is a CAS question, this little guy here. So we are then basically just defining our function, in this case solving for x to get my x-intercepts, as you can see there. Finding our maximum and minimum, so I, after sketching it, just subbed in 3 and negative 6, or you can think about that as our vertical translation and, where those maximum mins would occur. Lots of different ways that you can do that. Obviously want those as exact values as well. So I sketched it on my CAS so that I can basically just copy all of those bits and pieces there. Let's add the marking scheme. So our marks here, 1 for each of our endpoints, 1 for shape, 1 for all of our x-intercepts, and 1 for our y-intercept. So that's all 5 things that we require for this question. Key feature is question didn't necessarily say the coordinates of our x-intercepts. Actually didn't really say much in that regard, but if they were coordinates, I would write those as coordinates. In this case, in the green there, I've just got them as the x-intercepts. Sorry about the bell. Question 2ii. We've got a bit of a weird bracket thing going on. First thing I noted was that we have a reflection across the x-axis, so it's kind of flipped upside down. Just helps us get a bit of a sense of what we're working towards when we're starting our sketching. Here our period's pi divided by a half, which of course comes out to be 2 pi, very important feature here. I did my asymptote second, which was a bit silly here, but I've got x over 2 equals pi on 3. So that's when tan of x on 2 equals the square root of 3. Adding and subtracting my period. Not many x-intercepts, so having that period of 2 pi means that we don't have lots of x-intercepts, just these 3 different ones here. And the asymptote, same kind of thing. So x over 2 equals pi on 2. So whatever is in the tan function equaling pi on 2, giving us pi. Adding or subtracting our period of 2 pi k gives us negative pi, pi, and 3 pi. Again, marking this one's just out of 4, so we've got one endpoint on the far left there, one marked for shape, one marked for all of our equations of asymptotes, and one for our x-intercepts as well. Again, if they were stating wanting coordinates for our x-intercepts, we would state those as coordinates, but in this case I've just stated them as x-intercepts. Again, we don't need this y equals square root of 3 line, but it just helps us get a bit of a sense of the shape. It's that point where the gradient is 1 and it starts kind of changing its direction a little bit there. Again, that flip where we've gone from a kind of normal tan graph and reflected across the x-axis, really important here, getting that shape right. That's it, really. Enjoy, keep sketching, keep practicing. A good couple of questions where you're finding a lot of information and practicing all your trig skills. Trig mad skills, even.